In the previous exercise, you wrote a script that prompted the user to provide a password for the account that was being created. In this lesson, you're going to learn a few different ways to generate some random data, including how to automate the process of generating a random password. This way, you'll be able to improve your script by requiring less input from the user. And in my opinion, the more you can automate, the better. I have a terminal open up on my local system, and I'm going to move into the class folder. We're going to continue working on the local users system, so I'll just change directory into there. Now we'll start the virtual machine and log into it. Now we can connect to it and move into the Vagrant folder, into cd/Vagrant. Now I'm going to create a script called luserdemo05.sh. Of course, we always start out our scripts with a shebang. And then we're going to put a header to our file here, just a short sentence or two about the goal for this script. And so what this script does is it generates a list of random passwords. Now, before we do any real coding, let's look at the bash man page to see if it provides any way for us to get some random data. So let me save my changes here and we'll do man bash. And we'll just look for random. Since random is in all capital letters, and by convention variables are in all capital letters, I can probably assume that random is a bash built-in variable. And it is, and you can confirm that if you were to just go up the man page here until the header, and you will see that it is indeed in the variable section of the man page. But I'm going to scroll back down here and just read what this random variable is about. It says each time this parameter is referenced, a random integer between 0 and 32,767 is generated. So let's get back to the command line here by pressing Q to exit out of the man page and just echo $random and see what happens. Echo $random. And there's a random number, 4308. Let's see what happens if we access it again. And we get different numbers each time we echo the random variable to the screen here. So that's a pretty simple way to get some random data. Let's get back into our script here. So the first password we'll generate will just be a random number as a password. So we'll set the password variable equal to $random, and then we'll just echo that to the screen. Save my changes and exit. Of course, this is the first time I'm going to be executing this script, so I'm going to set the permissions on it. Chmod 755 luserdemo05.sh, and then go ahead and execute it. So if we keep executing it, you can see we just get a different random number. Just because I'm lazy, I'm going to do something here that's a bit of a shortcut. I'm going to do !V to execute the most recent command that started with a V. And this is called an event designator. And I go through this in my command line Kung Fu book, but it's a quick way to execute a previous command that starts with a given string. So instead of me having to retype out the whole vim space luser-demo05.sh, and I'm going to be executing this a lot, executing the script, and then going back and editing and so on and so forth, I'm just going to use this shortcut. So if I do !V or bang V and hit enter, we'll be back into editing our script. So just using $random might be good enough, especially if the user is forced to change their password on login. And if you're concerned about security, perhaps you would like a fairly long password. So let's do something like use 2 or 3 random numbers all together. So we'll reassign our password variable to random and just do this 3 times here. And we'll display that password to the screen. Okay, I'm going to execute !/luserdemo05, and I'm going to use my shortcut here, ! When you perform this shortcut, it actually displays what it executes and then executes it. I'm just going to hit the up arrow since I'm already here. So here you can see that we're getting some random data. The first password is just 1 random number. The second password that we're generating here are 3 random numbers together. And as you can see, they're varying lengths and whatever. So this also could be good enough, but we can do something better. If you think about it, something that is always changing is time. It's never the same time ever again. It's now, and then now was a second ago, and now is also a second ago, and so on. So that is some data that is always changing. So let's use the current date and time as the basis for a password to generate. So let's go ahead and look at the date command and some of its options. So obviously the date prints or sets the system date and time. The synopsis here is date followed by optional option, and the ellipses there says that you can have multiple options. And then also in brackets, which means it's optional, is a format plus followed by some sort of format. So let's check out the different formats that are available to us. And I'll just do a forward search with a / format and press enter, hit N to go to the next match, N to go to the next match, and so on. So here it says format controls the output, and each one of these looks like they begin with a %sign. For example, %lowercase a is the abbreviated weekday name, %uppercase A is the full weekday name, and so on and so forth. I want to point out %sign S. Keep going here. And %sign lowercase s is seconds since 1970-0101, January 1st, 1970 at 0 hours UTC. This particular date is called the epoch, and some people actually call this epoch time or Unix time. This Unix time, and it's also called POSIX time, by the way, or epoch time, is simply the number of seconds that have elapsed since January 1st, 1970. So I'll hit Q here to exit out of the man page, and let's just see what that looks like. We'll do date plus that says, hey, we're going to use a format. We'll use %sign S and hit enter. And so that is the number of seconds since January 1st, 1970. And we do it again and again. So 14 seconds, 15 seconds, 18, 19, 20, 21, and so on. So this number just continually increments every single second. So we could actually use this as a password. Let's get back to editing our file here. I'm going to use my shortcut, bang V. So we'll set the password equal to date. And remember that the $ opening parentheses and then a command followed by the closing parentheses, that takes the output of that command within the parentheses and assigns it to the variable. So the password variable is going to contain the value of whatever that date command returns. And then we'll just echo this to the screen. Okay, I'm going to execute this script again. And here we can see that it, increments by one number each time, 1 second each time we run it, or in this case, a couple of seconds, but not because I've been talking for a couple of seconds. In theory, this password could be guessed. For example, the more you know about the password generation technique, the easier the passwords are to crack. So if you know what day a password was generated on, and you know that there are only 86,400 seconds in a day, that means there are only 86,400 possible passwords. Now, you can further infer some more information and guess that the password was probably generated during normal business hours. So that leaves about an 8-hour window. Now you're down to about 29,000 possible passwords. Now, I'm getting a little bit off track here, but you get the idea. So let's find a way to make this even harder to guess. Let's get back to the man page for date. And I know the last command that I executed that started with an M was man date. So I can do !M and hit enter. So I want to point out this nanoseconds format. When you use this format, it prints the nanosecond that the date command was executed. So there's about 9 digits there. So that leaves us a lot more data to guess. So it'd be really hard to guess those nanoseconds because each time you run the date command, it has to be the exact to the nanosecond, and that provides us a lot more variation. So if we actually combine that with the epoch time, then we can get a long number. So let's do this. Let's run the date command. We'll say we're going to use a format. We want the second since the epoch. And then we also want the nanoseconds, and we'll hit in here like this and press enter. So now when we execute this, Maybe the first portion of the password that represents %S is only incrementing by 1 digit, but the last few digits there pretty much look random because they're based on the nanoseconds of when the date command was executed. So let's go ahead and use this as a possible password. Assign the date command to the password variable, and then echo the password. Okay, let's execute this script a couple of times. And so you can see that it looks fairly random. So that's a better password than just the second since epoch. Let's take this one step further by using checksums or cryptographic hash functions. A checksum is a numeric value computed for a block of data that is relatively unique. Checksums were and are used to verify the integrity of data such as files. For example, if you download a file and you want to make sure that it's not corrupt in some way, you find the published checksums for the file and compare it to the file you downloaded. Let's take CentOS for example. They publish SHA-1 sums and SHA-256 sums for their downloads. By the way, I didn't include the CentOS ISO that I'm about to use in the course download because it's about 700 megabytes at the time of this recording. So if you want to follow along with this specific section, you're going to have to download the ISO separately and then look at the checksums published by CentOS at the time you download the ISO file. Anyway, here are the contents of the SHA-1 sum text file published by CentOS. So for each file that they publish, they produce a SHA-1 sum that corresponds to that file. So the first file up there, the CentOS 7 dbd 1611.iso, corresponds to the C018577, etc. SHA-1 sum. So we can use the SHA-1 sum command on our side to run the SHA-1 mathematical algorithm against this file to return its checksum or SHA-1 sum value. So I've downloaded the minimal ISO, so I'm going to run SHA-1 sum on the CentOS 7 minimal ISO here and hit enter. So more or less, this number represents all the data in that single file. If it matches what is published, then you're virtually guaranteed that the data is exactly the same. So in this case, we have a known good copy of the CentOS ISO because its SHA-1 sum matches the published SHA-1 sum. I'll highlight that here. Here's the SHA-1 sum of our local file, and here is the published SHA-1 sum provided by CentOS that is supposed to correspond to that file. And so as you can see, it begins with 7.1 and ends with 4F, and ours begins with 7.1 and also ends with 4F. So we have the same file. They also publish SHA-256 sum, so let's use the SHA-256 sum command against that ISO and hit enter. Okay, it generated the SHA-256 sum for that file, and we can compare it to what's published. So let's look at the SHA-256 sum file that I downloaded from CentOS. Okay, this checks out as well. It should because the other sum checked out, but we're just experimenting here. So we have a SHA-256 sum that begins with 27 and ends with 86A. And sure enough, the minimal ISO corresponds, begins with 27 and ends with 86A. Let's change the file just ever so slightly and see if the sums still match. So I'm just going to add one character to the end of the file. And one way to do that is just simply do something like echo a 1 to the end of this file and hit enter. So now we've changed the file just a bit. So I'm going to back up here and execute my SHA-256 sum command again and see what happens. Now it doesn't match. The sum we receive begins with DA and ends with A1 here. And obviously this is a big long string in the middle. But if we compare that to the known good checksum, it doesn't match. So even a very slight change of data completely changes this checksum that's returned. By the way, there are other hash functions in checksum programs. So we can do a quick ls and user bin. So we'll just use ls-l user bin. For any programs that end in sum, we'll use a wildcard of asterisk and end in sum and hit enter. So you have CK sum, MD5 sum, SHA-1 sum, SHA-224, so on. So all these programs do pretty much the same thing. they take a big chunk of data and reduce it down to a single number or a string that represents that chunk of data to verify if it's the same or not. Okay, now let's bring this back to password generation. As you might have noticed, the checksums are actually hexadecimal numbers with 0 through 9 representing, well, 0 through 9, and A through F representing the values from 10 to 16. If we were to use a SHA-256 sum as a password, for example, that password would consist of 16 different characters, that 0 through 9 and A through F, and be 64 characters in length. That's a pretty darn good password. So let's turn the current date and time into a SHA-256 sum by piping the output of the date command as the input into the SHA-256 sum command. So we'll just run the date command by itself, date, and we'll use the epoch here. And now what I'm going to do is use a pipe symbol, which takes the output of the preceding command and sends it as a standard input to the following command, SHA-256 sum, and hit enter. Okay, so that's the SHA-256 sum of the output of the date command at the time it was executed. So obviously when you execute this, you're going to get a different value because when you're watching this video, it's going to be far past when I recorded it. So obviously you're going to be getting different data here. So how does this work, or why does this work? So we were running SHA-256 sum against files. Well, let's look at the man page real quick. So in the synopsis there, we have an optional option as well as an optional file. And it says, with no file or when file is a dash, read standard input. So remember with a pipe turns the output of the previous command as standard input in the command that follows the pipe. So that is how this works. And by the way, most commands work like this. If they take a file as an argument, you can also not use the file and instead use standard input via a pipe, and it will operate on that input. So I'll hit Q to exit out of the man page here. Since our goal here is to really generate a seemingly random set of characters as a password, we really don't care if the SHA sum remains intact or not. We're not going to be using that checksum to check it against another piece of data. We just want its output. So if we want to control the size of this generated password, you'll need to control the number of characters returned or displayed. One way to do this is with the head command. And just to briefly recap, how can you tell if head is a program on the system or if it's a shell built in? Well, of course, you can use the type built in, type-a head. Sure enough, head is user bin head, which is a program. So we can't use help head. What we have to do is use man head. Just a quick reminder there. So what head does is it outputs the first part of files, or the head portion of a file. Without any option, it just prints the first 10 lines of a file. You can also see this command, like the SHA-256 sum command. It says with no file or when file is a dash, read standard input. So we know we can use this head command in conjunction with the pipe. The first option that's listed there is -c, or dash bytes in the long form. And what that does is prints the first k bytes of each file. So if we were to do -c1, then it would just print the first character of the file. The next option is -n for lines, and that prints the first number of lines that you specify instead of the default first 10 lines. So let's go ahead and try both of these options out. So let's do head-n1 on Etsy password. And what that does is prints the first line of Etsy password. By the way, you can also do this, head-n space 1 Etsy password. So if you see either style, if you see someone like me who takes some shortcuts sometimes, I'll probably squish the value against its option. So -n1, for example. But if you see -n space 1, it's the same thing. So if you see either one, you know it's the same thing. And by the way, there's an old style of using this head command. So let's do this, head-1 Etsy password. So instead of using a -n followed by a number, just use the dash followed by the number. So here's how to print the first 2 lines of that file, head-2 Etsy password, and so on. Obviously, that's equivalent of head-n2 Etsy password or head-n space 2 Etsy password. Okay, let's just print the first character of the password file, head-c1 Etsy password. Let's print the first 2 characters, head-c2 Etsy password. So obviously the first line we can see it starts with the root. The first character is R. The first 2 characters are RO. Now, I'm sure you remember from the man page how you can use standard input instead of a file with a head command. So let's try that out. Let's generate some output from the echo command. We'll just do echo testing, and then we'll pipe that output as the standard input into the head command. And let's just print the first two characters, -C2. So sure enough, it returns TE. Now let's chain the date command, the SHA-256-SUM command, and the head command all together. So you can have multiple pipes, not just one pipe, but you can keep modifying the output and keep piping it into different commands. So we'll execute date. Second since the epoch, we'll get the SHA-256-SUM for that, and we'll print the first 8 characters. So if I hit the up arrow key and do that again, we keep getting a seemingly bit of random data here. If we want to make this even better, we can add those nanoseconds to the mix. So we can do date, S, in, SHA-256-SUM, head-C8. And we get even more random data. Now let's add this method to our script. So I'll go back and edit the file. We'll say we'll create a better password. So we'll use the date command with seconds and nanoseconds, SHA-256-SUM, head-C, and then we'll just say specify 32 character length password here. And we'll echo this password to the screen. Forgot my opening quote there. Okay. Let's exit to the command line and execute our script. Okay, so the password at the very bottom here, the latest thing that we're echoing to the screen is that 32 character password. And so each time we execute it, we get a very different result. So that looks like a pretty good password to me. But we can even take this further. Let's go back and edit our file again. Let's create an even better password. One way we can do this is just add some random numbers to the mix. So we'll do date plus S plus N, and we'll follow that by a couple of random numbers here. And then we'll pipe that into SHA-256-SUM. And then what we're going to do is, let's say we want to make this password 48 characters in length. So we'll do -C 48, and we'll echo that password to the screen. Okay, as you can see, we got a 32 character password and then a 48 character password here. So just keep running that and we get lots of different passwords here that we could use. Now there are other, probably way more secure ways to generate a password that has nothing to do with the current date, but this is really honestly good enough, especially if you're going to force a password change on login. But while we're at it, let's keep going and add a special character to the generated password file. Now let's start out by displaying the set of special characters that we want to use. And I'm actually going to store this into a variable right here in our interactive shell, so I don't have to keep typing these characters over and over again. So I'm just going to use a simple name of capital S. Now, again, that's not a best practice for shell scripting, but it's going to work for testing. And we'll use a better, more descriptive variable name for our script. But here in the command line, I'm just going to use the variable S and assign it to these special characters. Okay, let's echo those characters. Okay, those are our special characters. Now we need a way to randomly extract just one special character from that list. Now there is a command called shuf, S-H-U-F. Now let's see if it can do what we want. So let's look at the man page for this command. It says write a random permutation of the input lines to standard output. So this appears to work on entire lines. Now, of course, if you're unsure what a command does, well, just try it out. So let's do that here. Let's run it against the password file, for example, and see what happens. Hit Q to get out of the man page, and we'll just do shuf etc password. And let's do it a couple of times to see if we can figure out what it's doing here. So sure enough, it is definitely printing entire lines. And if we just look, for example, at the last line here, NFS nobody, RPC user, Einstein, and so on, that this is definitely displaying random lines out of the Etsy password file. So we need to break our list of single characters into individual lines so that we can then use shuff to do the randomization. So there happens to be a command called fold that can do just this. Let's look at the man page for fold. So the fold command wraps each input line to fit in a specified width, and it looks like there are some different ways to specify that width. And by the way, if we want to change our entire line of special characters into separate lines, then we simply need a width of 1. So if we look here, -B says it shows bytes, -C counts characters rather than columns, -W use width instead of 80. So it looks like we have a couple of different options here, -B, -C, or -W that we can use. It's not really clear here in the man page what the difference is. So what I like to do is experiment. So I'm going to use each one of these options and see if I can spot a difference between them. So I'll just hit Q to get out of the man page and return to the command line. So let's echo our string of characters here. Echo. Okay, now let's see what fold -B1 does. Okay, it lists our characters at a width of 1. It looks like our last character here is the equal sign, but it looks like there's an empty line here. Okay, well, let's see what -C1 does. Same thing. Let's look at -W1. Okay, so in my opinion, it's easier to work with the -W option because we don't have to account for that blank line that's being generated. So now let's pass this output into the shuff command. So we'll do echo $S into fold, and then we'll pass that to shuff, and we get a different order of the characters. Let's keep doing this a couple of times here. And sure enough, each time we run it, these characters are displayed in a different order. Now we're getting a random list of special characters. If we only want one special character, we can use the head command with the -C option followed by a 1. So let's do that. Head -C1. And sure enough, we get a $sign that time we executed it. This time we get a closing parentheses, a £sign, a closing parentheses, a caret symbol, £sign. So this appears to be working, doing what we really want, which is to get a random special character. Now, I hope you noticed a pattern in how I worked through this little mini challenge here. First, I had a goal in mind. I knew I wanted a random single special character. Next, I simply displayed what I had. In this case, I used the echo command to display the special characters. Now, if I was working on another problem, perhaps I would display the contents of a file or something else. Next, I changed the output so that I could work with it easier. The way you can change the output is by using that output as the input of another command. So I piped the output of the echo command into the fold command, and I kept doing this until I reached my goal. Taking the output and piping it in as the input to another command, and keep repeating that. So it's important to keep in mind the Unix and Linux philosophy that each program should only do one thing and that it should do it very well. So in our case, the echo command only displays output. It doesn't do any sorting, it doesn't do any randomization, and so on. It does its one job and it does it really well. When you need another job done, you'll need to use another command. That's why we use pipe, so we can string together all these specialized commands to make the system do exactly what we want. Some people call this data munging or string manipulation and so on. At any rate, I go over a lot of these techniques in my command line Kung Fu book, and it's filled with examples of small, specialized commands, all piped together to do something unique and useful. Anyway, before I get too carried away about how awesome Linux is and the philosophy and so on, let's go ahead and add this last way to generate a password to our script. We're just going to append a special character to the password. So we'll do a special character variable name, which is a lot better than just $S. We're going to echo our string of special characters. Pipe that into fold with a width of 1 column, shuff to randomize those lines, and then we're just going to extract one character from that, the first character. And now we're going to echo that password that we generated previously, and we're going to append this special character to it. Okay, let's save our changes and execute our script. Okay, so you can see that this 48 character password was generated, and then we just displayed that in addition to a random special character. So each time we do this, we'll get a different password that now includes a special character. So we have a great password, in my opinion, that you can use, especially if it's just a one-time password. So to quickly recap, in this lesson, you were introduced to the built-in variable of random, which generates a random integer each time that it's referenced. You also worked with a date command and used its formatting options to control its output. From there, we talked about checksums and specifically looked at the SHA-1 sum and SHA-256 sum commands. You also learned about the head command, which can display the top or beginning lines or characters of a file. Next, you use the fold command to transform a single line of text into multiple lines. Finally, you use the shove command to randomly select a line.